Good morning, good afternoon, or good evening, depending on what side of the world you're joining us from. Welcome. Today's webinar is the first series on MQTT for the connected car. On today's webinar, we will cover the basics of MQTT for automotive and transportation, as well as the advantages and future prospects of MQTT over QUIC technology for IOV. Additionally, Damon Motors, a smart EV manufacturer, will share their experiences using MQTT. Now it has transformed electric motorcycles. Please note we are recording this webinar. I'd like to begin by introducing our presenters. Today we are joined by Josh Eastburn and Rob Chartier. Josh is Director of Technical Marketing here at EMQ. Before starting his career in tech marketing, Josh worked on industrial automation projects supporting process equipment for semiconductor giants like Intel, TSMC, and Samsung, as well as applications in the petrochemical, food and beverage, and life science industries. As a marketer, his work has focused on educating the engineering community about MQTT and other technologies for IoT. Rob is a Senior Director of Cloud and Mobile at Damon. He's an experienced software architect with over 25 years of hands-on development experience, consistently delivering successful software solutions. He specializes in greenfield delivery and large-scale IoT solutions, specifically in the automotive industry. Recently, Rob was deeply involved in the vision, architecture, and creation of Damon Motorcycles' EV automotive cloud, which leverages .NET Core, MQTT, EMQX, Kafka, Actors, and the likes. So thank you both. The webinar, just so you all are aware, will last approximately 45 minutes, with the remaining hour being allotted for Q&A. Feel free to submit your questions within the Q&A tab below, and we will address them at the end. Without further ado, the floor is yours, Josh.
Thanks for that introduction, Rosemary. Certainly more than I deserve, but I'm excited to talk to you today, everyone, about MQTT and QUIC. This is going to be very much an introduction. There's a lot we could go into, and we will as part of this series, but today I'm going to try to give you an overview of the technology and, most importantly, its relevance for connected vehicle services. So these are a few of the brands that EMQ has worked with in the automotive, logistics, fleet management, services, transportation space, and kind of what we feel are the key drivers behind connected vehicle services technology, right? With the number one goal really being to reduce time to market for these new services, right? We know that demand is increasing on vehicles of all kinds to be more connected to each other, to the driver, to infrastructure around them. And while we are still forming an idea of what those actual services are going to be, we know that we need the tools to be able to deliver those services quickly as the market continues to evolve. And then, of course, there's a lot of aspects of the technology itself that need to improve along with that. That includes reducing the cost of the data involved in supporting those services. We know that interoperability is going to be a requirement as cars need to talk to each other and as cars need to talk to cities and so on. And then, of course, security and quality of service just become even more in demand as the demand for data increases and the number of consumers of that data increases as well. So I'm going to frame up our conversation about MQTT in those terms, and we'll kind of come back and see what relevance it has to those. So there we go. But what is MQTT in the first place? I'm going to take this sentence at the top and we're going to just break this down piece by piece, right? So first of all, MQTT is a lightweight IoT messaging protocol. What does that mean that it's an IoT protocol? That means that it's designed for edge devices, right? Or resource constrained devices that may have limited processing or even limited networking capabilities, or might be in an environment where there's not a reliable signal, right? And hopefully you can see the relevance for automotive right away from that. But the reason that that's important is because it allows MQTT to operate in a lot of different environments, right? So that could be on vehicle, that could be charging stations, that could be a mobile application that communicates with any of those other components, that could be embedded devices like wearables or other smart devices that get added into city infrastructure. They can all interoperate through MQTT, and that's a big part of why it has become the de facto standard for the Internet of Things. So it's lightweight and it's flexible. Specifically, when we talk about lightweight with regards to MQTT, what do we mean? So an important difference between MQTT and some of the traditional protocols you'll be familiar with, like HTTP, is it doesn't use a request response communication model, meaning the server doesn't have to reach out to the vehicle to request an update. Instead, each client on an MQTT network can be a publisher, right? And the publisher, the client, determines when it wants to send an update. So we call this updating on change, or we call this report by exception, or you might have heard of event-driven communication. So MQTT is designed for event-driven communication. And sort of obviously you can use that to build in a time-based communication as well, which a lot of people choose to do. But simply by choosing to allow these edge devices to provide an update if and when there is something to talk about, that already decreases the bandwidth requirements for communication. And then pair that with the fact that, again, being designed for IoT, right, for remote telemetry collection, MQTT uses a very streamlined payload compared to something like HTTP. So where you might be used to seeing lots of headers describing data and giving instructions to the server about how to interact with that data and whatnot, MQTT is data agnostic. It doesn't concern itself with the content of the payload. And in technical terms, it's a byte array. It's just a big chunk of data. And it's only concerned with moving that data around to where it needs to go. It does that using a flexible topic system. And so this is an example of a topic string in MQTT. This is just one that I made up, but it's compliant with sort of the MQTT standard. And this is how other clients on the network would identify a piece of data, a topic, that this particular client has made available or is publishing on, as we would say in MQTT terminology. So this is, for example, a geographical region paired with a VIN number that I randomly generated, and it's definitely not my car, so you can up the registration if you want to. And the speed telemetry that we might actually be interested in for that particular client. And so as somebody who's a subscriber on this network, and that could be, a database, a message queue, analytics package, or reporting package, might be interested in consuming this data. The only thing that it needs to know about this vehicle is actually just this topic string. So it doesn't need to know anything about the vehicle or anything else that's connected. It just needs to know what data it wants to consume. This is just like Twitter, right? You don't need to know the phone number and the address of the person that you're following on Twitter. You just say, I want to follow them. And then Twitter does the work of making sure that their updates show up in your feed. And MQTT is exactly the same way. When this vehicle has an update, a change in this piece of data, it will push that out to the server, and then the server makes sure that that data gets distributed to any interested subscribers. So that lets you do a couple of really interesting things. First of all, that means that your subscribers are decoupled from your publishers, just what I was describing. They don't need to know anything about what's going on over here. And that means you can develop applications on top of all of this data without actually knowing the specifics of who's publishing or what they're publishing. All you need to know is what piece of data, what's the piece of data called that I'm interested in, right? Those are kind of your hooks in. It also gives you a lot of flexibility in determining or in satisfying different use cases, right? Whether that's one-to-many distribution, right? Or many to one, right? We want to get all of this data into a database somewhere. It supports that, and many to many as well. So you can probably see that although I'm describing this as kind of a one-way flow from publishers to subscribers, it's actually bi-directional, right? Clients can be, or so rather, publishers can be subscribers, and subscribers can be publishers. And so you can have a flow of data back and forth. You might have some kind of interface where you want to push commands back out to a vehicle, for example. So that command and control use case is really common, even though it might be a smaller portion of the data than telemetry, right? That might be the bulk of it. You can still have that two-way pipeline. What does the server actually do in this architecture? Its number one job is, to secure those communications. MQTT communications are outgoing, right? Because it's edge-oriented. The client determines who it connects to, not the other way around. So there's already a level of security there. Each of these devices can be completely firewalled and still be able to create a bidirectional connection to the MQTT server. But the server is also responsible for, making sure that it supports the, appropriate level of encryption, check certificates, sets access controls on which topics are allowed to be published or subscribed to, and so on. It manages each of these connected sessions. And then, of course, its primary function is message delivery. And there are different quality of service guarantees and whatnot that an MQTT server might provide, and it will make sure that those are being upheld in its communication. So you'll often see an MQTT server called a broker, because that is kind of its primary job, to broker communications or to be the middleman between all of these participating clients. Let's see, now where this starts to get fun is as you kind of grasp the basic model, right? You can see that there are lots of other ways to bring data together through MQTT, because it is such a widely adopted standard. So manufacturing data could be incorporated into the same namespace, the same data infrastructure. City infrastructure or other smart devices that become part of a vehicle's environment could also share their data, or that data could live together in the same system. Likewise, the backend consumers don't just have to be databases and message queues and things like that. MQTT clients are very simple to implement and could be added in all kinds of business applications, fleet management services, over-the-air updates, telematics, could directly consume data from the broker and then make decisions, publish that data back out to update publishing clients or edge clients that are part of the network. So what does that mean for us in terms of our big technology drivers? First of all, speed to market. MQTT is very simple to implement. What I described is the core of the specification. It's not a long specification. It's certainly evolved over the years since its first version, but it is easy to implement, and it's at the same time quite mature and supported in lots of different languages. Because the resource requirements are not high, it's also suitable for both edge and cloud applications, and you'll find support on both sides. In terms of cost reduction, MQTT was originally developed by IBM, but released under a royalty-free license. So it is free, it's open source. If you want to build a proof of concept, that costs $0. And yet you can use its basic features that we described before, right? Report by exception and its streamlined payload. It's not unheard of to see significant reductions in the amount of data or the amount of bandwidth that's consumed compared to your traditional protocols. And then more recent evolutions of MQTT have added features like shared subscriptions that we're not going to get into, but are worth looking up. They can have an impact on data distribution and load balancing for large scale networks like the kind that we're talking about. In terms of interoperability, MQTT is an ISO standard, and it's also the de facto standard for IoT services on cloud platforms and for smart devices. And again, it's suitable for both edge and cloud applications, meaning you can have one protocol across the entire network. For security, it supports client authentication and access control lists, which I mentioned before, meaning the MQTT server can authorize different clients to publish or to subscribe to different topics that are available in the network, and becomes your single point of managing all of that communication. And then TLS encryption, connection encryption, is standard on most MQTT brokers right now. Finally, in terms of quality of service, MQTT offers a granular quality of service control. So that's per topic and per client. So each client, whether publisher or a subscriber, can request a specific quality of service level. There's multiple levels. And then the MQTT server will make sure that if critical messages, right, it need to get through, then it has the ability to queue up those messages and wait for clients to come back online if they're dealing with some kind of network issues that might be interrupting their connection. And that's all part of the fault tolerance that's built into MQTT. Again, that's why it's an IoT protocol, right? Because the expectation is that these devices are going to be in challenging environments, right? Or might only come online, temporarily every now and then, and need to communicate some basic communication and then go back to sleep, right? Designed to support those kinds of use cases. And so while we're not getting too deep into this, it's important to understand that that is built into the protocol. Whereas with other protocols, you need to design those kinds of mechanisms in yourself. And then again, the fact that MQTT is the standard for the Internet of Things right now, it's proven itself, its ability to scale in so many different use cases. At EMQ, our MQTT broker is called EMQX, And we have independently benchmarked that at 100 million simultaneous connections. So scalability at the order of magnitude that we're talking about for automotive applications is not a concern with MQTT. I want to take a break though and invite Rob to comment. Rob, this was my overview of MQTT. Do you feel like there's anything I left out, anything that you really like that I didn't mention?
No, like, it was a great overview. I love the pub sub analogy with Twitter. That was great. I was like, oh, I'm going to steal that for sure.
Yeah.
Great way to explain it, I think. Yeah.
Twitter for machines. That's how I describe it in one sentence. Okay, well, thanks for patting me on the back. I'm going to keep going then. So the reality, that was MQTT on paper in the ideal, right? The reality of it is, of course, more complex, right? That's why we're here talking about this stuff, because we're technology people and we know that the devil's in the details. So MQTT is designed for resilience as a protocol, right? But having a single MQTT broker, of course, is going to be an obvious point of failure. So an EMQX broker is going to operate as a cluster natively. Okay, so let's put that down as table stakes, right? High availability is critical for pretty much any application that we're talking about in the automotive world. In addition, while many applications, and certainly applications that you build yourself, can have an MQTT client embedded in them and be able to communicate directly with your MQTT broker, there are lots of other applications that may not have that option or that need to go through another kind of service in order to interact with an MQTT broker. So part of what we offer is then that integration layer, right? 40 plus native integrations out of the box that will allow you to connect backend consumers to that MQTT data, which you might also want to do for performance reasons. And then there's the whole edge aspect of this, right? MQTT can run onboard vehicles, right? At the edge. So you could have an MQTT broker there. You can also have it in the cloud. And that use case might make sense for a lot of different reasons. In particular, if we're talking about reducing data or streamlining data production is probably a better way to say it. We have the ability to run those services on board in a way that allows for pre-processing of data in the vehicle before it gets sent out to the cloud, right? Again, addressing the need for cost reduction and being able to satisfy various use cases that need to happen in the vehicle, right? So building in that kind of a messaging bus on vehicle is something that you might want to consider. But then, of course, that adds a layer of complexity because you're managing services on the edge and you're managing services in the cloud. So in addition, we have an edge cloud platform, which provides a single view across the entire network. So end-to-end management, deployment, updates of services on both sides of that network. So that's what a real world solution is going to look like, apart from kind of maybe the idealized version of MQTT. And that's going to come with a lot of other requirements as well, which I'll touch on here. So in addition to what MQTT offers here and kind of this upper layer, at EMQ, we include other tools, development tools to help improve your speed to market, right? Like the native integrations that I mentioned, a rules engine that allows you to do data transformations without writing separate applications to do that. And then we also provide operations and maintenance services we can take over the entire operation if that's something that you need. In terms of cost reduction, I mentioned in-vehicle data processing, which is important to consider, and then the lower cost of ownership for end-to-end management of the entire system. In terms of interoperability, we know that we don't yet have the kind of standards that we want to have for connected vehicle services, right? But those are in development. And so we support schema registries, meaning the ability to define data structures that then our MQTT broker implements across the entire network, as well as the ability to use our rules engine to do low-code data transformation of data in motion. In terms of security, one of the biggest requests from all of our customers is support for different kinds of authentication mechanisms, right? Because typically we're putting a broker into an existing ecosystem, right? Rarely are we're starting from a blank slate. So often there's authentication requirements that we need to meet. And then we've also added additional layers of encryption, right? The ability to encrypt the payload itself rather than just the connections. Those can all be used together. And then finally, quality of service. We talked about, having a clustered architecture, designing for high availability from the get-go. And then, of course, there's MQTT over QUIC, which a lot of people are wondering about. But that is designed specifically to address issues around quality of service. And I'm just going to touch on that lightly because this is a very deep subject. We will certainly get into it in the future. But here is a comparison of your sort of traditional MQTT stack, right? MQTT built on your encryption layer and your basic TCP/IP that connects the internet, right? Everything these days. MQTT over QUIC, or QUIC specifically, is an alternative to TCP that seeks to solve some problems of mobile internet, right? Originally designed by Google to provide a better experience for clients who are moving between networks, right? You're changing from Wi-Fi to cell, you're changing from cell tower to cell tower, and that can result in lots of different interruptions. TCP, because it tries to guarantee ordering, can cause issues actually for automotive clients. Head of line blocking is a big one that comes up that you might be familiar with. So QUIC seeks to address those specific issues, right? It's built on top of UDP, and then QUIC itself handles the ordering of data and then just encapsulates the TLS handshake as well. So that results in faster handshaking, right? It's easier to make a connection or to restore a connection with QUIC, as well as being able to smoothly migrate IP addresses as a vehicle changes from one, let's say, cell tower to another cell tower, from network to network. And because QUIC exposes, it's able to interact at the application layer, we can do tuning of those interactions to reduce the data loss or to be able to detect data loss quicker. And then on top of that, we're working on building features that would support multi-streaming and more fine-grained flow control or prioritization of data streams. I'll just give you one example of testing that we have done independently of MQTT built on QUIC instead of TCP. And this is a simple case where we start messing around with NAT rules, trying to force the client to have to rebind. So in a typical TLS connection, we see this drop, right, in data, right, while that negotiation happens, right? This is on our end. The broker is having to find the connection again, bring in this new IP address. With QUIC, we are able to manage that seamlessly without a drop. So those are the kinds of results that we're looking for when we think about the future of connected vehicle services, right? The ability to negotiate a difficult environment, right? This is a real world environment where we're dealing with things like weather, we're dealing with things like going through tunnels, and we don't necessarily want to wait for carrier services to improve their quality of service, right? We can do something on the application side to deliver a better experience for the end user, while we also increase the demand for data and connectivity. So that is QUIC in a nutshell. And I'm sure there will be questions about that at the end, but I want to make sure that we have enough time to talk with Rob today. So we're going to talk about how MQTT connects the safest motorcycles on the road. Rob, to start off, can you tell us what we are looking at right now in this picture?
Yeah, this is one of our prototype bikes, actually. It looks like in Vancouver, it looks like that's a Georgia Viaduct of Vancouver here. But yes, it's a relatively early prototype, and I think that's Dom, one of the co-founders, riding it. Yeah, it's a pretty sweet little machine for sure.
Is this the Hypersport?
That is the Hypersport. Very, yeah.
Now, I know there's a great story behind Damon. Let's see, I'm gonna turn this off so I can see you. There we go. Yeah, so tell us about the Damon story. What's the origin of the Hypersport, and then how did you get involved?
Yeah, the going way back 6-7 years ago, our founder Jay Gerard, he co-founder and CEO, he was in, I think it was Jakarta, and he saw just like thousands and thousands of bikes just streaming by. And what he noticed, there's a lot of accidents. There was people hitting things. It wasn't complete chaos, of course, but he noticed that it's amazing how many motorcycles are on the road with zero safety kind of mechanisms built into it. Almost every single car, you can't even open your door anymore because the car's going to lock you in. You can't do really anything because it's very much keeping the rider, the driver safe. And motorcycles, there hasn't been very much innovation, I guess you could say,
Yeah.
around safety. Something as simple as pulling up to a light, you always got to keep your eye on the car behind you until he comes to a complete stop. You never know if he's not going to stop for you, which is
You're a biker yourself, right?
Yeah, exactly. So I'm super paranoid, and you got to look. So, yeah. So what we did is just in our dashboard, just gonna have a rear view camera always on, so you always can see the people that are coming up behind you. Yeah, so Jay realized very early that kind of, well, I think the first path they went down is looking at accessories for motorcycles, and then they soon realized, let's just do the whole motorcycle. And then, modern is EV. So that's kind of, they evolved over like 3 years into this final idea of this, the bike actually behind me, the title screen on the slide deck that you had. Yeah, this is where we're at. The designers are from Italy, are kind of the motor itself is from Northern Europe. Like it's absolutely amazing, the technology going into this bike.
Yeah, so I think when we talked last time, you said that this sort of hasn't been a standard for motorcycles for some reason, right? And
Yeah.
this is kind of the first time that someone's really investing in making a bike that is as safe to operate, right? Or has the same level of safety features in it as what we might expect from a modern EV, right?
Yeah, absolutely. Motorcycles are actually relatively hard to do something like forward collision warning, because you're turning, right? Cars are kind of like turn kind of side to side. We lean, right? So doing forward collision
so you have more
warning,
degrees of freedom that you're dealing with there.
Yeah. So there's a lot of complexities in that, and I think that's a big reason, like the forward collision warning isn't there yet. Is technology is just getting to the point of being able to. We're getting smarter with that stuff, I think. Then your basic radar kind of blind spot detections. Yeah, bikes aren't really shipping with it, and I don't know if it's a lack of customer demand or what, but yeah, it's definitely a big area we're exploring for sure. Yeah.
Okay, so what did Damon bring you in to do specifically for their motorcycles?
So the role I'm in is the senior director of cloud and mobile. So the entire cloud infrastructure, utilizing technology like MQTT and possibly QUIC or over MQTT5 to Kafka and all that, just that general architecture of the cloud end to end, and then how that kind of feeds data down and onto the phone. The phones is, phones are pretty important for human life these days. So we push everything down to it. And, what's a bike without an app? It's the bike. You got to have an app.
Well, yeah, I mean, like we talked about in the beginning, right? The market demand continues to evolve. And I've heard people say, that cars are becoming, an iPhone on wheels. People expect that it's going to integrate with their digital life, because that's where we're getting stuff done all over the place, right? So tell me a little bit more about that, actually, because you mentioned safety as being a big priority for Damon. What else is part of the vision of kind of the digital ecosystem for Damon Motorcycles?
I think what we'll see over time is more, once we start shipping this guy behind me, once we start shipping him reliably, you'll start seeing more and more models hitting different markets. Like the scooter market's huge, right? So we'll look at starting into that, and then obviously global distribution are probably the big ones that we're going to hit. Europe being I think our first after North America.
Okay. So number one task is being able to support this network that is going to scale up over time.
Yes. Yeah. So global scalability. So stuff like protobuf over QUIC through MQTT, for example, is appealing because just of the performance. And you mentioned RTT, and you mentioned, the pain points that we're starting to see on some of our clusters when we're testing at scale. Yeah.
Okay, so that's your number one focus. And then you also mentioned mobile app integration, other kinds of services that you're building on top of that. Can you name off a few?
The mobile app is obviously the key one, and we have some pretty tough goals, like from a bike event, say of a harsh braking event, getting that to a push notification on a phone, and I think our goal is sub 5 seconds. But putting aside all of the infrastructure issues. So we're trying to get that down fast because it's, again, part of that safety. One is keeping people safe, as the other is letting other people know that there was an event happening. So that kind of driving data down to where and when it matters is important. Yeah, that was probably the biggest thing.
Yeah, great. And so how did MQTT become part of the solution to all of that?
Right. Yeah. I go back 10, 15 years for using MQTT for a lot of different technology space. In a previous connected car company, MQTT was still quite young. So we were looking at it to replace the current system, which was UDP with basic sequencing numbers. So it wasn't a very robust system, but it allowed a bidirectional communication. And anyways, MQTT was still quite new. And then over the years, I've just been keeping my eye on it, been doing a lot of pet projects around the house, doing a lot of different clients have started putting it in. RabbitMQ is a pretty useful piece of software as well. We're looking at stuff like that. And then, we get to Damon and we start looking at clustered EMQ solutions or MQTT solutions. We look at MQX, and it was fantastic right out of the box. So that's kind of that was that next big push there to choose is the kind of the broker, the messaging kind of platform, and that was the first one. And second, we needed to kind of take millions of topics and compress them down into a few kind of partitions of topics on the server. So that's why we chose Kafka. And with Kafka, you get event streaming and stuff too.
Yeah. So tell us a little bit about how that integration works, or how do those components work together in your architecture?
Yeah, we try to keep things as in those big I guess pieces of technology. We try to keep it fairly minimum. So we have the EMQX with the rules engine, transforming it to just partitioned, and I think into Kafka, partitioned into Kafka, and I think our partition key is like the VIN, for example.
Okay.
So then it just kind of gets slimmed down into, right now in our testing clusters, we've got 16 partitions, for example. And then we have this small set of nodes in our cluster just around subscribing to Kafka and publishing it to an actor system. And that actor system, essentially, you can think of that as a digital twin for the bike. So the bike has this digital twin always running in the cloud, which represents that bike. So
we're hitting all the buzzwords today, man.
just hammering it. Yes.
Yeah, digital twins are such a big thing. Yeah. And I feel like in my experience, I've rarely heard somebody successfully describing a real use case of, not use case, that's not the right word, but like a successful implementation. That's kind of what I'm going for, right? Yeah. So tell us more about that aspect of it.
In a couple of different aspects. One is this mobile app can connect to that digital twin relatively quick and painlessly through WebSocket, essentially, and gets instantaneous updates, all secure, just 100% up to date and kept active, which is important for customers. And then let's see. I went brain dead there for a second. So the actor system
is fed by data from Kafka, which is fed from EMQX, right? I got the flow right?
Yes.
Okay.
EMQX, Kafka to the actor system. And yeah, so it's a digital representation of the motorcycle, right? So we have customer service portal, we have a complete UI based around that. Wow. And we actually can treat an actor, say by its VIN of, hey actor, give me, or hey VIN, give me your current state, give me your current logs, request a reboot of this specific, module on there. Like how's the ABS system doing? We can ask the actor, and the actor will know how to act on behalf of the vehicle.
I see. Okay.
And does that request response through Kafka and EMQX and back. So it's kind of the thing that can take care of that.
So you've also segregated, then you have the live communication happening on one side, and then you're communicating on your back end with the actor system.
Yeah, the security guys are least privileged and they don't trust anybody. So we've got big domains there and we're not allowed to talk to each other.
That's probably good. That's probably for the best.
Yeah.
Okay, so we've kind of got the big picture. Tell me a little bit more about what other kinds of services you have built on top of that actor system. You mentioned customer service, so you're able to interact with the bike through that service.
Yeah. Over the year updates was a big one as well.
Okay.
And there was, sorry.
Oh yeah, we hear about that a lot. Like we get a
Yeah.
lot of requests for people who are trying to build OTA systems. Sure.
Yeah. And so we have a bunch of APIs that can manipulate those actors or talk to the actor, hey, go triggering the bike to actually come in and check in for an update and that sort of stuff. So around OTA, we decided not to use MQTT to publish the binary because we're potentially going to go up to 16, 24 gigabytes of data. So
Sure.
just
Yep.
that would be abusing MQTT. So we stuff it in some page block storage on our cluster and have time limited URLs. And so MQTT facilitates that communication back and forth. Is, hey, do I have an update? Yes, you do. And here it is. And
Bingo.
here's
Yeah.
the cryptographic signature and the hash and all that to do all that work, right?
Setting up the whole exchange.
Yeah.
Yeah.
So MQTT is that vital piece back and forth for all that stuff with that actor kind of doing the work as well. Yeah.
Yeah, fantastic. Can you talk at all about the kinds of results that you're seeing at this point?
Yeah, sure. Yeah, we're probably overestimating, but we're expecting when a bike is actually on the road, about a message per second. So depending on how successful Damon is, which we all hope there's selling millions and millions and millions of bikes. Well, if you get into say 10,000 bikes concurrently driving, that's 10,000 messages per second. So that's when, the number I think you mentioned, was it 100 million connections or 100 million? Yeah, that's when we start. 100 million is huge and we'll get there. But this is those are the ceilings that we're constantly kind of conscious of is where the factor by 10, the 1,000, the 10,000, the 100,000, the million. We're always kind of keeping our eye on that. Yeah.
Yeah. Okay. And so you said that with the long term, right now you're looking at actually rolling out over the next year or starting later this year. Is that right?
Yeah. Supposedly the last schedule I saw, which was last week, was it has some bikes shipping very late this year.
Okay. Yeah. And then so tell us kind of what are like you mentioned those thresholds, right? Over the next 5 to 10 years, how are you expecting to grow? Or what kind of, let's I should say, what kind of capacity are you planning for?
Yeah, and I think that's the big thing right now. We do in Vancouver, Surrey area, in my area here. There's we built a pretty big manufacturing facility. And then we're also looking at the facility near our California office as well to really start pumping out the first, 1,000 vehicles that got to come out of probably the California location. I think that's still to be determined, but either way, so you'll see it kind of very slowly ramp, and then we'll hit a kind of inflection point where we'll kind of just skyrocket when everything starts really ramped up. And I suspect that'll take quite some time though. That's the issue is not just supply chain issues are kind of dwindling away, but there's just so many issues that we're facing with not even just manufacturing the bike, being able to manufacture it, and everything else coming along with that. So,
Sure.
Yeah.
Any I guess lessons learned or recommendations for other people? Obviously, people who might be attending today who are trying to build these kinds of competitive service offerings for their own vehicle networks?
I guess have patience, I guess, is probably all I'd say, especially on the architecture and design. Is I know the cost of firsthand. I know the firsthand cost of having a bad system. So at Mogio, essentially a connected car IoT solution. It was an OBD dongle. There, one of the designers put in. We used Kafka as well, and we went to. It wasn't an actor system, but there's some steps in there that got incredibly expensive from a CPU perspective. And essentially, the first week we had to keep adding servers because we just couldn't keep up. It was the infinite loop problem is some people. Yeah, so just be careful and take time and test. This was all software. The whole world's going to be a software world. So in my eyes, and people aren't putting the time in to make sure the quality's there.
Gotcha. Yeah, sure. Do your due diligence. Speaking of data transmission, and there's something that you just mentioned there that made me think about to ask what you're doing on the bike in terms of sourcing data, or what do you have going on in terms of MQTT happening on vehicle?
Yeah, so the bike has two networks, a
Five.
CAN network. Oh,
I think that was our 5-minute warning there.
there's a 5-minute. Okay, so we've got the CAN. I'll be quick. We have the CAN network and we have an Ethernet network on the bike, and our dash is actually a full-blown Linux OS. So we're running the Nano MQ from EMQ as well. We're running Nano MQ on that dashboard, and essentially it's kind of like the broker on a vehicle. All this Token Hub model, everything gets published into that local broker, and then we essentially have one consumer of that acting as kind of a proxy to lift that data up to the cloud, and that
So
proxy takes
sitting
care
on
of TLS and
that's subscribing to everything from that broker and then bridging to your cloud broker.
Exactly, and it subscribes to the cloud, the topic that the egress topic for that bike, and then instruct stuff like, hey, we need to do an OTA, or hey, we need to reboot this, or query this for data, that kind of stuff. So
Fantastic. So you have a local broker on the bike, and so everything on the bike obviously you mentioned you have a CAN network also, so there's some translation happening in there. Is that happening through Nano MQ?
Right now, no. Right now we have custom software that's doing like the CAN to TC, or CAN to MQTT bridge, basically.
Okay, then into the broker and then to the cloud. Okay, fantastic. Well, I think we've got a lot of questions queuing up here, and probably it would be a good time to move on to audience Q&A. So
Josh and Rob, thank you for sharing. Such an exciting time for Damon. Rob, thank you for sharing your story. Yes, we did receive quite a number of questions, so we want to try and get to them, as many of them as possible. So I'll go ahead and just fire them up, and you guys can decide amongst the two of you who would like to go ahead and take that on. So the first question we got is, privacy is a key concern for me, but MQTT seems light on security. How do you address that at Damon? And also, when can I get a bike? Right, Rob, I think this one's for you.
Yeah. So MQTT, we're going to be going over TLS. And if we can get QUIC on HTTP 1.3 and TLS 1.3.1.4, whatever it is, the latest is that's how we're keeping your data private and secure. And we're looking at a feature in our dashboard that we haven't really mentioned. It's in a beta right now that will allow customers to toggle, how private they want things. We're actually contemplating a slider of very private, don't share, to okay with a little bit. It impacts the app because the little bit means we're just going to tune the precision on the GPS of the data that we report. So the app experience is, instead of sub-meter precision, it'll be say 150 meter precision, a city block or something.
So is it actually interacting with the GPS on the vehicle, or is that just sort of throttling the data?
That edge computing piece actually will basically tune that data out. We'll bring the resolution down. Okay. It's all around privacy and customers. I'm a cloud guy, so I know how incredibly important privacy is and security.
Okay, and the other half of that was, when can they get a hands on that first bike?
After I get my hands on my own. Like I said, later this year, there is plans to ship a limited number of bikes, and that one I think is, though you'll hear more in the coming weeks on that for sure. And then for the general population, expect it next year is the realistic probably response.
And the fact that they're all hearing it today, everybody on this webinar gets first dibs on that pre-order, right?
I think that we'll get on the wait list as soon as possible, right?
Exactly. Well, we do have another question. So this person wants to know, can you use MQTT in vehicle to vehicle and vehicle to infrastructure communication in the connected vehicles? How much impact or change would it make on existing systems if we use MQTT in the connected vehicles?
So I don't know, Rob, what your take is on this. I was just at a connected vehicles conference a few weeks back, and this subject came up, talking about some of the challenges, right, in kind of evolving the technology here. And one of the big conversations that came up repeatedly was around standardization, right? And how, as an industry, we're still looking for standards. We know that we will need to establish them. We'll know that vehicles of different brands will need a way to talk to each other. maybe the question, I don't know if I'm interpreting this correctly, but could MQTT be that standard? And I'll hand that over to you, Rob. Do you see MQTT as a viable inter-vehicle communication protocol?
I think vehicle to vehicle, it might be a bit of for me, it's seemingly, especially if it's like within proximity, say over Bluetooth or some local LAN connection, kind of weird LAN connection, vehicle to vehicle. I think MQTT would probably be too expensive. Bluetooth or something, maybe like beacons or something like that. Just simply because you're driving 100 miles an hour down, or 50 miles an hour, not 100, 50 miles an hour down the road, and that car zooms by, and you don't have, a lot of time to establish that connection. Yep. So that's probably the biggest one. And then vehicle to infrastructure, yeah, that's absolutely a key use case. Yeah.
Yeah, I agree with that.
All right. Well, thank you. Well, here's another question here for you. Do you see the new IoT standard Matter coexist with MQTT, or what are the advantages of MQTT over Matter?
So I think Matter is getting popular within home automation, but let's just set that aside for a second. I just had a conversation with the World Wide Web Consortium a few weeks back, and they're proposing their own standard called Web of Things to be a protocol for across, the Internet of Things, trying to, multiple use cases. So, I think right now where we are, it's pretty fragmented, right? So we certainly need some standards, like which one's going to win. I don't know enough about Matter, I guess, to really comment on that. But what I do know is that a home automation environment versus, a mobile internet environment, right, is pretty different. Correct me if I'm wrong on sort of the design parameters for Matter. Rob, any thoughts?
Yeah, I'm with you, Josh. Yeah, Matter, I see it as definitely kind of within the home or within a building, or the like very close proximity for that. So Matter's more like, it would be, I don't think it'd be equivalent to MQTT. You could probably, Matter would be more like the underlying threads of communication through, I guess, in a sense it could be that, but it's not like pub sub, it's not quality of service. It's like Zigbee or Wi-Fi.
Yeah,
that's probably the comparison there.
You're a big home automation guy, right?
Yeah, absolutely. I'm looking forward to more Matter devices myself.
Yeah. So it has its applications, but in a different sphere.
Yeah.
Okay, well, Rob, this one looks like this next question is directed to you. We are considering both MQTT and gRPC for our vehicle network. Did you do any tests comparing those two options before going with MQTT, or what are your thoughts on how they compare?
I think the biggest thing, we didn't actually compare MQTT and gRPC because we just leaned really into MQTT simply because it was the flexibility. You could you can back it over HTTP or WebSocket or QUIC, and that was the more compelling argument for us to go to MQTT. There was a lot of push in the industry with that. I did a lot of research investigation on that topic, and I really like that. gRPC and almost implied as protobuf for a transport framework. We're looking at protobuf for sure for that messaging, the serialization format for our messages. But I really tend to lean towards the pub sub mechanism of documents. My background is much more on larger design for within the enterprise, and we use pub sub and a lot of other kind of enterprise messaging patterns. So it really fit more of that architectural need, I think.
Yeah, I hear two things that you're mentioning there. One is the communication model itself, right? Pub sub versus request response. And then also the type of data that you're handling, where I think we've seen gRPC come up is like you mentioned for your OTA use case, right? Where you're using MQTT to set up the transaction, but then you're using a different protocol for the actual file delivery, right? And I think we've seen similar things where people are using gRPC for high bandwidth data in parallel with MQTT for sort of the overall orchestration.
Yeah. And I think it was a year ago, gRPC and it was looking at QUIC for the behind the HTTP3 kind of stuff. So I haven't checked on it in like a year, but yeah, that looks pretty interesting.
Cool.
All right, Josh, this next question is for you. So in your use case, you mentioned location VIN signals. If each VIN and signal use different topics, there might be a chance topics of having more than 10,000 topics. How many topics can be used on MQTT broker? How this can be handled on the EMQ broker for performance side?
Sure, that's a great question. So yeah, that's definitely a broker dependent question, right? So the number of sort of levels in that topic hierarchy that are supported, that's going to depend on what you're using. Off the top of my head, I think I might have to ask Carrie if you know how many sort of topic levels we support, but it's I'm going to say it's a ridiculous number. It's a very large number of topics. Yeah, Rob, how deep are you guys going?
We've hit, I think, in our topic structure is very similar to that, and that's important because you can optimize the topic structure based on how you're doing it, based on the subscriber, or like we basically transform it right into Kafka, so our topic just becomes a string as part of the stream within those. So topic kind of construction and the order of that is very important based on like I said, the consumers. But I would probably lean towards optimizing it from those use cases versus optimizing it for having 10,000 or more topics. I think the MQTT spec, I can't remember if it does limit the number of topics, but it's huge. I don't think there's really limits in the number of topics.
Yeah, just to make sure that I understood you right, did you say better to go deep on the topic string than to go broad within a given level?
Like every architect will say the same answer.
Yeah.
Is it depends.
It depends. Yes, that is the only correct answer. Yeah.
All right, so we have a few more questions here we're going to try and get through. Josh, is there any particular device on the market that you can recommend us to use, like a gateway that allows connection through LoRa, 4G, 5G networks? I already have my EMQX server running on Google Cloud, but still I'm looking for the best gateway option.
Yeah, I've heard that one come up a few times in the last year. I'm not an expert on LoRa itself. I know we've supported use cases like that before. Certainly, I certainly wouldn't want to try and give you a recommendation for a particular gateway. That I don't know. Did you dabble at all in LoRa, Rob, for what you're doing?
I haven't.
Right.
Yeah, I would probably it depends on the situation, but Raspberry Pi, the lower receiver essentially, and
yeah, that's another it depends question, right? Like I feel like we need to know more about the application, right? Is this for fun or is this for money? That definitely makes a big difference. Yeah, sorry, I couldn't give you something better there.
Okay. Here's the next one here. Do you have a software simulator tool or tools so I can vary the MQTT data packets to determine payload and data usage per vehicle? And it looks like they're specifically asking about a bus.
Did you say for a bus?
For a bus, yes.
Oh, okay. Yeah, I'd be interested to hear what you guys are using at Damon. But yeah, EMQ does offer an Xmeter load testing tool that allows you to customize different scenarios. And then that's at cloud-based. I think we can also do an on-prem solution. Yeah. What do you guys do, Rob?
Yeah, our QA engineering guy kind of went a bit crazy one month, and they decided to deploy into Kubernetes an actor system, because we love actors. That it's almost like the digital twin but reverse. These actors we're deploying are vehicle simulators. You can say, hey, vehicle A, run this scenario. You're a weekend warrior, which means Monday to Friday the bike's parked, and Saturday and Sunday he does two-hour trip from Vancouver to Whistler, and then Whistler back down, kind of idea. All simulated data getting sent in our standard protocol and all that stuff. So we decided to do that, and since it's in Kubernetes, you can say, hey, spin up 10,000 of those, point into this data center, and throw in a little bit of chaos and start degrading some connectivity issues to the server and stuff. So it's all home ruled stuff, but it's we can scale to essentially infinite number of vehicles in a simulated environment.
Gotcha. So that's the roll your own option. Yeah, Xmeter definitely supports a level of customization. It is designed around scenario planning. Probably not that fine grained, but you earned the ability to do that by rolling your own.
Yeah.
Okay, so we have two final questions we're going to try and squeeze in here before we're up for time. Rob, do the bikes have built-in connectivity with LTE and or 5G? And how do we choose which cell carrier?
Yeah, the game plan as it stands right now is yes, the ones that are shipping for the public consumer market will have an LTE modem built into it. And it'll be like most other automotive OEMs. You don't know who's the carrier, nor will you ever care. Right now, the cost is going to be, the burden of the cost will be on Damon for the life of the bike, is my understanding right now. So you'll never see that there. We are looking at why a customer would want to pair their bike on Wi-Fi, and advantages if we have a pretty big OTA update to incentivize you to get the bike on Wi-Fi. But for now, we're kind of looking at LTE as the solution. Yeah.
Okay, then this final one is again directed to you, Rob. Do the CAN nodes need to be running MQTT stack as client, or the CAN node can just send raw CAN frame or messages, and the bridge node will convert all the CAN messages to MQTT messages?
Convert.
Yeah, convert. So we've got essentially the way that I kind of explained it to the team, the way we went down, the path that we went down is kind of publishing and subscribing mechanisms. So we actually have this mechanism that wraps CAN in a publisher or a subscriber. And we have essentially a daemon running on that Linux machine that's subscribed to CAN messages, and we'll just deserialize them into the proper kind of data type and republish them over on that MQTT broker. So it's all it's doing is just imagine like a little in-memory program that runs at start and has a watchdog kind of keeping an eye on it, and then just doing this data translation bit. Extract, transform, load, except for transform, it doesn't do anything. Yeah.
Yeah, we solved that with a product called eKuiper that can consume CAN and convert it into MQTT.
I saw that, and I'm going to start digging into that too.
Yeah, yeah, that's fine.
Yeah. Very well. Well, thank you, Josh and Rob. Love to be able to continue this conversation. Unfortunately, we're going to have to go ahead and wrap it up. But really appreciate your time this morning. So this does conclude today's webinar. Just so you all know, we'll be sending out a recording of this session shortly, should you all want to hear a replay. We'll also be producing a white paper on MQTT and its applications for connected vehicles, so look out for that. And as I mentioned earlier, today's webinar is the first in a series. So if you enjoyed today's webinar, stay tuned for the next one. And thanks again for joining. Have a great rest of your week. Take care, everybody.
Thanks, everyone.
Thank you. Bye.